Hi everyone, welcome to the world of simplified electricity. I am Kumar. In today's lecture, we will learn types of electrical loads. Electrical loads कितने प्रकार के होते हैं, हम जल्दी से जानने की कोशिश करेंगे. Types of electrical loads. Basically, electrical load तीन प्रकार के होते हैं. जैसे कि आप देख सकते हैं कितने प्रकार के होते हैं, तीन प्रकार के. First one is resistive load. Second one is capacitive load. Third one is inductive load. Resistive load is indicated with this symbol. Capacitive load represented with this symbol. Inductive load is with this symbol. Do remember. Whenever we are talking about resistive, inductive or capacitive load, what we have to know about those loads, basically what is the relation between voltage and current in a pure resistive load, inductive load and capacitive load. Now we are talking about pure resistive load. The symbol is this one, what we have seen. Whenever we are giving AC supply to pure resistance, what will happen? The two basic things which we should know, that angle between voltage and current is zero. Angle means you can see every point where they are meeting on this line, they are meeting together, means there is no angle. The angle between voltage and current in case of pure resistive load is zero. It means they are in same phase. What is the angle between voltage and current for the resistive load? Your answer will be zero. This we can indicate with this phasor diagram. Both are in the same phase, so is there is an angle? No, the angle between voltage and current is zero. Now quickly we see some of the basic examples in our household of pure resistive load. कोई भी लोड प्योर होता नहीं है, फिर भी अगर रेसिस्टिव लोड की अगर हम बात करते हैं तो हम वी कैन गिव एन एग्जांपल ऑफ दिस incandescent bulb, this heater and your iron box. Now we see quickly what is an inductive load. इंडक्टिव लोड कुछ नहीं होता, कॉइल जिसमें हो वाइंडिंग्स आप देखते हो तो सारे इंडक्टिव लोड ही होता है. बट इन दिस स्लाइड वी आर टॉकिंग अबाउट प्योर इंडक्टिव लोड. द सिंबल ऑफ प्योर इंडक्टिव लोड इज coil shaped, this symbol. Okay, so whenever we are giving an AC supply to any coil, that is inductive load, so what happens? The two basic things again, what is the relation between voltage and current for inductive load? As we have seen for the resistive load, the angle between this blue line voltage and red line current was zero. There was no angle between voltage and current for the resistive load. But in this case of pure inductive load, you can see this is voltage, this is current, which is something current is lagging behind. Current is lagging behind this voltage by 90 degree. This is the main difference in case of pure resistive and pure inductive load. In the same thing is represented here in this waveform. Now we see what are the examples of inductive load. Gentlemen, we have seen the symbol of inductive load. This is a coil shaped. Okay, let me tell you, around 80% of our electrical load are inductive load. Yes, gentlemen, जहाँ कहीं भी वाइंडिंग है, जहाँ कहीं भी कॉइल है, that is inductive load. Just imagine about your home only. अपने घर में जो सीलिंग फैन है, that is coil based, so it's inductive load. And that pump, motor, everything is made up of windings, so those are inductive loads. So then you can take an example of washing machine. It is also main component is a motor. It's made up of winding, inductive load. If you talk about refrigerator, in which compressor is the main load, compressor is nothing but a motor operated, so it is also the main constituent is winding. This is also a inductive load. So these are all the examples of inductive loads. As we have seen about resistive load and inductive load, now we will going to learn about capacitive load, pure. The symbol is, you can see in this picture. Whenever we are giving an AC supply to any capacitor, again two basic things that we have to know, that what is the relation between voltage and current in case of capacitive load. As we have seen in the inductive load, the current was lagging behind. In inductive load, what we have seen, current was lagging behind by this voltage by 90 degree. But in this case of capacitive load, this current which is shown in the red color and voltage is shown in the blue color, the current is now leading this voltage by 90 degree. This is the basic difference between capacitive and inductive load. Can we accumulate all the things together? In case of resistive load, there was no angle between voltage and current. Voltage and current was in the same phase. Angle between voltage and current was zero for the resistive load. In case of inductive load, what we have seen, this current was lagging behind this voltage by 90 degree. In case of capacitive load, this current is leading, the word is leading this voltage by 90 degree. The same thing we can see in this waveform also. This current is leading this voltage by 90 degree. Gentlemen, there is no specific examples of capacitive load, but whenever we are talking about underground cable and overhead transmission lines, तब क्या होता है, ये जो cables हैं with respect to this ground, what they create, capacitance. ये cables ground के respect में capacitance create करते हैं. ये एक तरीके के capacitive load on the cables. And we are talking about the transmission lines, they create capacitance between two transmission lines and with respect to the ground. with respect to the ground एक capacitance create करते हैं. इस form में capacitive load को देखा जा सकता है. Again, thanks for watching my channel Simplify Electricity. Please do subscribe with Kumar. Jai Hind.